Welcome back. In this lecture, we will look at rational agents. So here are the objectives for this lecture. All right, so let's talk about the agent. So here we have an agent, and it interacts with an environment. So one way to kind of think of this to make it concrete is think about a robot interacting with the world. But note, it doesn't necessarily have to be a robot. It could just be an algorithm to identify what's in a given digital image, and the environment are just the images that are given to it. So from the environment, the agent ingests sensor input. It has some type of sensors, and it takes that in from the environment. The agent then conducts what's called perception, where it makes sense of this sensor input. And the results of perception then go into reasoning, where then it figures out what to do. Now, when it figures out what to do, it's going to then do something. It's going to take an action. And those actions then change how that agent is situated with respect to the environment. So now what makes an agent rational? So here's our agent again, and let's look at a couple factors that we consider when determining that an agent is rational. So first, there's a sequence of perceptions. Now maybe that sequence is just one thing, but we'll assume that there is a sequence. The agent can also have some prior knowledge. So we could think of, example, if you're an agent and you're playing a game of baseball, you're observing what's happening, who's on a given base at a given time, how many strikes or balls the pitcher has thrown. And you can make sense of all that because you have prior knowledge of the rules of the game. Then there's possible actions. So again, the pitcher in a baseball game, that person gets to decide what kind of pitch they're going to throw. They have different actions. And then, of course, there's a performance measure. So again, in a game like baseball, it's pretty easy to measure the performance. Did the pitcher throw a strike, or did the batter hit a run and hit the ball out of the park? So how do these things go together? Well, we say an agent is rational if for a given sequence of perceptions and the prior knowledge, it takes an action that maximizes the performance measure. So that pitcher in the baseball game is not going to throw a pitch that, based on the current situation, is going to lead to the batter hitting it out of the park. He's going to select a pitch that is going to maximize his performance measure, which is trying to win the game, avoid having that batter hit the ball. And so, of course, in a sports game like that, that agent is going to take an action that is rational. And rationality is defined with respect to these four items. Now, if we're trying to, say, model a human being or model something that has other considerations, we can still consider that as a rational agent, but maybe we change the prior knowledge available, or we limit the perception, or we adjust the performance measure. And so these are key things to consider. It's mainly that the combination of these four things, regardless of how they're defined, work together in a way where the agent is trying to maximize performance. Now, one interesting thing that has been occurring in the field of machine learning and the larger field of artificial intelligence is the performance measure sometimes gets very tough to define, especially in things like large language models, where what is performance? Is it simply to predict the next word of a paragraph, or is it to predict the next word in a way that aligns with some preconceived notions? And so maybe there's multiple objectives, and this is where in modern times we're seeing a lot of difficulty, and this paradigm breaks down a little bit. But all that aside, in general, this whole idea of the rational agent works really well for a wide variety of applications, which is why we are covering it in this course. So thank you again for tuning in, and please keep checking for more content. Thank you.